Let's be real for a second. For a long, long time, CSS was just seen as the easy part of web design, right? Making text blue, changing a background color, but that story has totally changed. Today, we're going to dive into how modern CSS has become this incredibly sophisticated engineering tool, the real backbone of the complex, beautiful websites we use every single day. Have you ever stopped to think about how you can browse the exact same website on your giant desktop monitor, then your tablet, and then your phone, and it just works? It adapts, it looks great everywhere? Well, that's not magic, and it's definitely not an accident. It's the central puzzle of the modern web, and the elegant solution is hiding in plain sight, inside CSS. So, how exactly does CSS pull this off? Well, here's our game plan for this explainer. We'll start with that multi-device challenge. Then we'll look at the flexible layouts that solve it, and the rules we use to keep our code from becoming a total mess. We'll also cover a core principle called the rule of least power before getting to the fun stuff like animations and what's coming next.
All right, first up, let's get right to the heart of the problem. Making a single design work across 1,000 different screen sizes. This is the world of responsive design.
The core idea here is called responsive web design, or RWD. The goal is simple: one website that provides a great experience for everyone, no matter what device they're on. And what's kind of wild is that HTML is already fluid by nature. If you just type text with zero styling, it naturally wraps and fits any screen. So the job of modern CSS isn't to create that fluidity, but to tame it and control it with precision. So how do we give the browser these instructions? The key tool is something called media queries. Think of them like little if-then rules for your design. You can literally tell the browser, hey, if the screen is wider than 800 pixels, use this layout. But if it's narrower, use this other layout instead. This is the secret sauce that makes the whole thing work. So media queries set the conditions, but we still need something to actually build the layouts that can bend and adapt. And that brings us to our first major pillar, Flexbox.
Flexbox is designed to do one thing, and it does it incredibly well. Arrange a bunch of items in a single line, either a row or a column. The name really says it all. The items can flex. They can grow to fill up empty space, or they can shrink to fit into tight spots, and it all happens pretty much automatically.
Now, to really get why Flexbox was such a game changer, you have to remember the dark ages of CSS. We used to rely on this total nightmare of hacks and workarounds with things called floats and positioning. It was messy and super unpredictable. And now, all that pain can often be replaced with just one single line of code. That is a massive leap forward. And getting started is just incredibly straightforward. First, you tell a parent container, hey, you're a Flex container now. And boom, all the items directly inside it immediately become flexible little soldiers ready for your command. From there, you just use simple, easy-to-read properties to line them up and space them out perfectly. Stuff that used to take hours of pure guesswork.
Okay, so Flexbox helps us wrangle the layout. But what about wrangling the code itself? Because as websites get bigger and more complex, our CSS files can turn into a giant bowl of spaghetti code. So how do we keep things clean and manageable?
You see, the bigger a site got, the harder it was to manage one single massive style sheet. Like the source here says, a more organized approach was needed. You change one little style and it would accidentally break something completely different on the other side of the website. We needed a system. We needed to treat CSS like engineering.
And the solution is to think like an architect. We use a set of principles called CSS Architecture. The big idea here is modularity, breaking things down into small, independent, reusable components. And methodologies like BEM give us a clear naming system to enforce this. You name the main block, say a search form, then an element inside it, like the search button, and maybe a modifier to describe its state, like if it's a big or small button. It makes your code predictable and so much easier to understand.
Now, a huge part of clean code is this principle of don't repeat yourself. If your company's brand color is used in 20 different places on your site, you shouldn't have to type out that color code 20 times. That's where CSS Custom Properties, or as we all really call them, variables, come into play. And just look at how simple the syntax is. You define a variable, usually for the whole site, give it a name with 2 dashes, and set the value. But the real magic happens later. Let's say the company decides to rebrand and change their main color. You don't have to go on a scavenger hunt through hundreds of lines of code. Nope, you change it in this one single spot, and that update cascades everywhere instantly. It's an absolute lifesaver.
So we've got these really powerful tools for layout and for organization. But this brings up a fundamental question that every single web developer has to ask themselves. When both CSS and JavaScript can do the job, which one should you actually use?
This is a classic dilemma. Should you create that cool animation using CSS, or should you write some JavaScript to do it? What about a simple drop-down menu? Do you build it with pure CSS, or do you need a script? Well, the answer lies in a really simple and elegant principle. The answer comes down to a web development philosophy called the rule of least power, and this quote sums it up perfectly. The idea is to always use the simplest, most basic tool that can actually get the job done. You start with HTML for your structure. If that's not enough, you add CSS for presentation, and only when you need complex logic or interactivity do you reach for the most powerful tool in the shed, JavaScript. And the reason this rule is so important really boils down to performance and purpose. Each language is built for a specific job. Browsers are absolute masters at handling CSS animations. They're optimized to run them super smoothly. Trying to do that same animation with JavaScript is almost always cluntier and can make your whole page feel sluggish. JavaScript's real power is for handling user interaction, managing data and complex logic, not just making things look pretty. Okay, so our foundation is solid. It's responsive, it's maintainable. Now we can add the polish, the fun stuff. Let's look at two powerful ways we can enhance our projects, animations and frameworks. So on one hand, you've got CSS animations, which let you add all this life and motion right inside your style sheet, and they're super performant. And on the other hand, you have CSS frameworks. Think of these like amazing cheat codes for development. They give you a whole library of pre-built components so you can build a professional-looking site in a fraction of the time. And the world of frameworks is just huge, with different tools for different tastes. You've got frameworks like Bootstrap that give you ready-made components like buttons and navbars right out of the box. Then you have a totally different approach with something like Tailwind CSS, which gives you tiny little building blocks that you piece together to create completely custom designs at lightning speed. There's really a tool for everyone. All right, let's zoom out and put all these pieces together. What does this all mean for the way we build things for the web today? So I think the big takeaway here is that CSS has well and truly grown up. It's not just a simple language for painting by numbers anymore. It has become a genuine engineering discipline with its own principles of architecture, modularity, and even a bit of logic, all designed to solve the very real challenges of the modern web. I mean, when you really think about it, with responsive layouts, variables, conditional logic, CSS is starting to feel more and more like its own kind of programming language, isn't it? It has all these powerful new capabilities that once belonged only to JavaScript, which leaves us with one really fascinating question. What's the next big problem it's going to solve?